came to the 13th topic, that is related to elasticity. So where we mainly discussed about types of moduli or coefficient of elasticity. There are mainly 3 types are there. So based on which what kind of questions will come. So if you consider the concept of elasticity is nothing but if you apply deforming force on an object and after removal if it is able to regain its original shape, that kind of property is called as elasticity. Now let us consider what happens when you apply deforming force on an object. What happens when you apply force on an object, deforming force? So if you consider just general force, the body may move from rest, the body may be come to rest from the motion. So it may move from rest to motion or from motion to rest, and it can change its direction. But other than this, if the body is not moving even after applying force, then there is a change in shape, there is a deformation in the body occurs, and that force what we call it as deforming force. Now if you apply that deforming force on an object on particular surface area, then the force per unit area we call it as stress in case of solid body and pressure in case of liquid or gas. Now based on that, if you apply deforming force, the parameters or dimensions of the body changes, maybe in terms of length or in terms of volume, sometimes even the position. So based on these 3 cases we divided. There are 3 types, and of course we generally define from Hooke's law that the stress developed due to deforming force always directly proportional to strain up to elastic limit, where strain is change in the parameter or dimension, or better to say change in the configuration by original configuration. Suppose there is a change in length by length, delta L by L, change in volume, delta V by V, like that. So now the very first thing is Young's modulus. Young's modulus is what? So the longitudinal stress by longitudinal strain. So here delta L by L is called longitudinal strain. When the length of the object changes, then the strain is called longitudinal strain. Or it is like 2 types generally. One is tensile strain, and means the stress applied corresponding to change in length, we call it as 2 types, that is tensile stress and compressive stress. So one is when the length increases, tensile stress, and when length decreases, then compressive stress, and the corresponding fractional change in length delta L by L is called the longitudinal strain. Similarly, when there is a change in volume, like if you kept one object under the water, due to the pressure applied in all the directions, the volume decreases. So due to the application of pressure, there is a decrease in volume. As value decreasing, we will take it as minus. So that ratio, the force per unit area is stress, that only here we are defining as pressure by fractional change in volume, nothing but volume strain. This also you can say like hydraulic stress or volume stress. So volume stress by volume strain is called bulk modulus. And the final one, when the body position slightly changes, when the bottom is fixed and you applied force on the surface, then if it gets shifted by some distance, it gets shifted by some angle, then that angle theta is called shearing strain or shear strain, and the corresponding stress we call it as shear stress. So the ratio of shear stress and shear strain is called rigidity modulus. And in case of Young's modulus, usually we discuss about a wire, cylindrical wire. So when you stretch a wire, the length increases and the radius decreases. Then you can define one more thing called Poisson's ratio. So that is, there is a increase in length, decrease in radius. So the strain in radius is called lateral strain. The strain in length is called longitudinal strain. So the ratio of lateral strain and longitudinal strain is defined as Poisson's ratio, that is sigma. And there also you will derive one relation between all these four quantities, that is y equal to 3k or 3b times 1 minus 2 sigma, y equal to 2 neta times 1 plus sigma. This is what. And when you consider the entrance point, most of the time they will ask questions based on Young's modulus, where very frequently they will ask questions based on the energy stored in a stretching wire, that is nothing but elastic potential energy. When you stretch the wire, the configuration changes. Due to the change in configuration, the work done will be stored as energy. What kind of energy we call it as? Potential energy. Here the property, what is there? Elasticity. That's why it is elastic potential energy. Now come to the work done. So work done is half into F into delta L. Here why half coming? Because when you apply a force F, now the total length increased by delta L, but the center of mass come down or displaced by an amount only delta L by 2. That's why the work done is force times displacement. Displacement is how much? Delta L by 2. That only we call it as elastic potential energy. And one more thing we define here, energy density. What is that energy density? Energy density is nothing but energy per unit volume. So if you divide this energy or work done by volume, volume means what? Area into length. So force by area will become stress, delta L by L will become strain. So energy density will become half into stress into strain. So based on this basic data only, we can understand what kind of questions we can get in the entrance. So here I have taken some of the sample questions in what way they will ask in the entrance point of view. Let us try to understand how we can use these data or formulae in solving the simple and logical questions based on this modulus of elasticity. Let's take the first thing. So what is the very first question? The very first question is all about find the stress when a wire stretched to double its length. So y equal to F by A delta L by L. Immediately you can take, because stretching of wire. So length changes. Length changes means what happens? Young's modulus comes. Then it is stretched such that length became double. So L became 2L means what is delta L will become 2L minus L, that is L. So this is the change in length. Now what is delta L by L? 1, because delta L is L. So the what is y will become F by A, that is Young's modulus is equal to the stress applied. So this way you can apply the formula whatever you have. Now the second question, what is the elongation due to the own weight of a wire? So what is the elongation? Again elongation means what? Young's modulus. The formula is same, F by A by delta L by L. But here if you consider a wire hanging from a fixed support, let's take the mass is M and the length of the wire is L, then you can replace like the weight will act at the center of mass mg. That means the weight will act on effective length of how much? L by 2. So the situation you can replace like a wire of length L by 2, it acted by an external force how much? Mg. So that what is the Young's modulus will become? F is mg by area delta L by L. L is how much? L by 2. So 2 will go up. So y equal to mgl by 2a delta L, or else what is the corresponding extension will become? mgl by 2ay. This is the stretch or extension in the wire due to its own weight. Now you cannot neglect the weight of the wire. Usually most of the cases when you take the wire and attach some weight or apply some force, we will neglect the weight of the wire. But in this case you should not neglect it, because they are asking the extension due to its own weight. Now similarly, when same force applied on two different wires, there are, let's take two different wires are there, two different wires of same material. So there are wire 1 and 2. Now y1, y2, and the lengths are L1, L2, and here area A1, A2, nothing but pi R1 square, pi R2 square. So here force applied F1 and here F2. Then here delta L1 and here delta L2. Then y1 will become F1 L1 by A1 delta L1. y2 will become F2 L2 by A2 delta L2. Then if you compare y2 by y1 will become, first y2, F2 L2 by A2 delta L2 times by y1. So F1 L1, and this will go up. So A1 delta L1. But according to the given situation, here the force applied is same, F1 F2 cancel, and they are having same material, y1 y2 cancel, so that delta L1 by L1 times A1 equal to delta L2 A2 by L2 by A2 delta L2. Now from this, so it will become delta L2 by, if you bring this side, delta L2 A2 by L2. That means the value of delta LA by L remains same. So you can write the relation like, in comparison, delta L into area by L remains constant, or delta L into R square by L remains constant, or else delta L is proportional to L by R square. This way you can take. In another simple way, what you can say, when the comparison type questions comes, y equal to, what is the formula? FL by A delta L. Then FL by A is pi R square delta L. Then here itself you consider whatever same for both of them, you take it like constant, because in ratio they get cancelled. F is same, y is same. Then delta L, if you bring this side, pi is also constant. So delta L is proportional to what? L by R square. So if you are thorough with the mathematical application, then these kind of things you can do it on your own. So then you can compare. Like one question here, you take this question, YA by YB, the ratio of Young's modulus they have given. Then YA by YB they have given as 7 by 4, and LA 2 meter, LB 1.5 meter, and the radius of A is capital R, radius of B is radius of B is 2 millimeter. Then if they stretch by same length, so delta L1 or delta L for A equal to delta L for B for same load, that means force applied on A should be equal to force applied on B. Then just now we have taken Y2 here YB or YA. YA by YB if you take. YA means what? FA LA by area of A into delta L for A times YB FB LB and whole divided, that will go to numerator, that is area of B and delta L for B. But here FA FB cancel, both are same. Delta LA delta LB cancel because both must stretch by same length. And then YA by YB they have given as 7 by 4 and LA is 2 meter and LB is 1.5 meter and area of B means pi, what is RB square? 2 millimeter whole square divided by area of A is pi R square, pi get cancelled. So if you solve this, then you will get the radius of A, that is capital R. So this way comparison questions are important, but calculation is also very important. Try to do the calculation quickly. Don't leave any question without completing, even when you are practicing also. So this way you can do the questions based on Young's modulus. And sometimes very simple questions also they can ask, like here the question is they have given length 2 meter, area 50 millimeter square and stretch by 0.5 millimeter and mass is 250 kg due to from its lower end. So when a mass is attached at its lower end of length 2 meter and area this much, then this is the extension. Then they are asking what is y. What is y? FL by A delta L. FL by area is pi r square or F is mg, the weight of the body attached, into delta L. But here while substituting, convert the units into SI terms all. Then only we will get it. This is meter, this is millimeter, this is millimeter. You convert this into meter, then only you will get the answer properly. Like mass is 250 kg, G 10, length is 2 meter, pi approximately 3.14 times radius. Directly area they are given, so no need to pi r square. What is area? 50 into 10 power minus 6, because millimeter is 10 power minus 3, whole square is 10 power minus 6. Delta L is 0.5 but 10 power minus 3. So these kind of conversions if you take properly, then you will get. Then take the calculation 0, 0, 5, 5 are. Then 5.1. Then 0.1 if it goes 0 will come. So 10 into 20, 200, minus 6 minus 3 minus 9, if it goes up 10 power 9. So 2 into 10 power 11 Newton per meter square. So this way you should do the calculation. So here the question is simple, but in the examination hall you have to do the perfect calculation. Then finally sometimes the questions will be asking based on bulk modulus, based on the formula minus B by delta V by V, or you can take it like one more thing here, compressibility, that is 1 by bulk modulus, where P is change in pressure, delta V by V is the volume strain. Now here one question they are given, derive in case of compression of a liquid that delta rho by rho is 1 plus K times delta P, where delta P is increase in pressure and rho is density. So what is the relation between density and the modulus of bulk modulus? K nothing but bulk modulus. You can represent with K or B. So here consider the equation of bulk modulus, that minus P by delta V by V. And what is the formula for density? Mass by volume. So mass remains constant, that's why delta rho by rho is minus delta V by V. Minus because when volume increases, density decreases, to represent that. Now here V equal to minus P by delta V by V is what? Minus delta rho by rho. So if you take this side, delta rho by rho equal to P by B. But here delta P they have taken, so change in pressure you take it as delta P by B. Now here delta rho by rho is delta P by P by B. So here if you want, have to take the relation. Oh sorry, here it should not be delta rho, it should be rho dash. What is rho dash? Final density after compression. What is K? Here the compressibility of the liquid, which is nothing but, as I told, 1 by bulk modulus. So delta rho is rho dash minus rho by rho equal to delta P by V is nothing but K times delta P. So rho dash by rho minus 1 equal to K delta P implies rho dash by rho equal to 1 plus K times delta P. So this is the way you can understand how to solve the questions based on the Young's modulus and sometimes bulk modulus. But I finally say one thing, that remember the formulas, do the calculation carefully, then you can get the marks based on this particular topic. So hope you all understood. Thank you so much. We will continue our next session with our next topic.